Hi everyone. Lunch was good? Everybody's tired? Everybody's just sitting here and waiting what will happen? Okay, let's see what will happen. We'll find out in a few moments. So, oftentimes when you want to log or see what is going on in your application, well, you start developing and it looks something like this. You run Gradle or Maven or whatever and you see whatever logs are running by and you look at those and, well, you figure out what is going on. And then you put it into production or try to test it out and maybe you run it with cat to see what is in your logs. And at some later point, maybe you will start using tailf to see what is happening in your application. Who is using tailf? Okay, a few. So you quickly see what is happening in your application and then you move on, maybe you go to less plus capital F. Anybody knows what less plus capital F is doing? Or what is the difference to tailf? Yes, the other thing that is very nice about this is once you're using less plus F, you can just Control C and then you can move up and down and you can also search in the file, so you can just slash whatever, or if you want to go to the end of the file, you can use capital G and you can just move around in the file any way you want. So that's kind of nicer. And then you're often saying, well, this is fine. And this works somehow for some time, more or less. Then you move it to production and maybe you have multiple services, and the more services you have, then it will start looking like this maybe. So you start having 3 different windows of logs. And, well, you keep trying that. At some point you have so many services that you only see like 1 line per service anymore. And you still say, well, maybe this is no longer fine. Like, that's the point of what you want to do. Lower? Okay, we'll try to keep it lower. Okay, the screen is still there. Cool. Once everything is on fire, it's kind of too late. So we want to figure out what to do before everything is on fire with logs. So we want to log all the things, basically. That's the general idea. So I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats. Historically, we've come from full-text search, and if you search on Stack Overflow or Wikipedia or GitHub, the search goes through our software. But we also do a lot around logging, because nobody cares really about the logs to store them, but everybody wants to find something helpful in the logs. So we always see logging as a search problem. And, well, we put everything together, and if you have any questions, by the way, around anything, you can go to Slido. If you post your questions there, I will see them at the end and we can answer them. Otherwise, you can just remember them and I'll ask you at the end. If I don't have enough time to go through the questions anymore, I will just post the result on, or the answer on Twitter, which should be my Twitter handle. Wait, let me quickly fix that. That's not where this should point. This should be, where is it? That's the nice thing about Markdown slides. You can just fix everything as you go along. So this is where I will post the answer if I run out of time. So you can see the answers there. Anyway, so coming back to the Elk stack, you know, Elasticsearch, Logstash, Kibana, those are the 3 components to log. Is anybody using that for logging? Okay, good. Maybe I can show you some new tricks around that, so let's see. So that is very widely used, but I don't want to go into the use cases. I more want to go into the tech side of how to properly do stuff, or what has been changing over time. So at some point, we added this new component called Beats, which is like a lightweight agent or forwarder, which will take your data and will just forward or ship it somewhere. And, well, we tried to come up with this logo at first, because you can see it's the elk, but it also has the bee body, so that's the belk or the elk bee. And you can see it's a combination of the horns and the bee. However, since we're always about scalability, this is not very scalable, because what happens if we add another open source product, then we probably have another letter, and then we need to figure out another animal, which is getting harder and harder, and also we need to redo the entire branding again. So we kind of gave up on that, and we now just call it the Elastic Stack. And whatever open source product we have, we can just put that into that stack. And it looks something like this. So at the bottom, you have beats and logstash. This is how to get your data and potentially how to parse it. Then you can store it in Elasticsearch, and then you can search it and visualize it in Kibana. And that's pretty much what we'll do. Speaking of licensing, most of the stuff we do is Apache 2 licensed. We have a couple of free but not open source features, and then we have some additional paid features. But I'm not covering any paid features today, so everything I'm showing you is free to use. So generally, I build pretty highly monitored Hello World applications. And today, again, it's a very simple application, but we'll try to collect the logs and do the right things with the logs. Okay, so I will use SLF4j for logging from our application. I will use logback as the log appender, and I will use MDC. Anybody remembers what MDC stands for? Map Diagnostic Context. Anybody remembers what MDC is doing? It's basically to add structured information to your logs. So for example, if you have a user session or a user ID, you can enrich your events with that user ID, and afterwards you could search like, what has this specific user been doing? Or if a user complains and says like, well, there have been errors on your page, you could say, okay, let's figure out the user ID, let's look at the logs of that user and see which errors happened to that user and why that happened. Or whatever you have, like it could be an IP address or a special use case or an application flow. You just want to collect or get down to whatever action has happened there. That's what MDC is giving you by giving you structured information. By the way, if you want to use any other programming language, even in PHP, you can properly log by now. They have monolog, which is their log appender, so there is no excuse in no language do you have to kind of like not do logging properly. And two anti-patterns before we dive into that. First, we are not logging with println, right? I hope everybody agrees. Otherwise, we can have a discussion about that afterwards. And the other thing we want to not do is to have a too tight coupling between our logging system or centralized logging system and our application. So I don't want to have like a specific library in every single file that I have or in every package that I create. I want to kind of have that decoupled. So I want to have my general log appender, and only the log appender cares about how to centralize logs. And the rest of the system is just working generically. Okay, I'm using the latest version of our stack, 6.5, which came out last week, and I hope everything is still working. So hold on, and let's see where we can take this. So the first thing you generally want to do is you have the good old classical log line, then you want to parse it. So what that generally looks like is you have your log file, you have file beat as like, I always say it's kind of the tail F over the network and on steroids, because it's really just tailing that file and sending the contents of that file over the network. And that is sending it to Logstash then. Logstash is doing the parsing for me, and then we store it in Elasticsearch, and Kibana can show me what is in my logs, which might look something like this. So here you can see whatever is in logs, we collect that. Here, the exclude lines, there you could say, for example, we're logging on tracing level, but we don't want to centralize the logs on tracing level because it might be just too much information. But if we want to debug something, we might still want to have that in the file. But we don't want to centralize it, and you could exclude that, though I have commented out the line here. And what that could look like, let's see. I have a very simple application here. It's really extremely simple. So I have a class that is running a loop. Every time the loop runs, I log a trace statement. I have a random session, and then I count the loop just to see where I am. That I set as the MDC information, so it's kind of the structured information in my log. And then I'm using, depending on some rules, I'm either logging an error, a warn, an info, or a debug. What is the pattern that I have here? Which is very common for interviews. Yes, this bus. Depending on where you are or by what the number or the loop iteration is divisible, you will get a different kind of message. And I'm just using FizzBus to log here. And in total, you can see every entrance will log one trace and then one of these here. So if you look at the loop, how many log statements should we get in total?  2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2 Who is for 20? Who is for 40? Who is for more? Who is for less? You're rather undecided. Okay, let's try it out. So let's simply run that, and then let's head over to the log afterwards. But before we head over to the log, let me show you. Okay, this is what we're basically doing here. I configure like here is my log rule, what to actually do, and then send that information over to logstash. And by the way, I'm collecting some information from the host where this is running to see on what operating system is the entire thing running. And here is my log rule, so you can see here I'm collecting that line. So heading over to Kibana. If you have never seen it, this is Kibana. This is the current version of Kibana. Let's see what we have here. So here in the parse index, I have just sent that. Let's refresh that. You can see now we have 42 log events. Let's see what are my log events. So my log events look something like this. You can see here we have the session and the loop that we had, and then we have a log message that we have applied. And for example, we could say, I want to see the loop to see how many times this has been running. I hope this is large enough for everybody to see. And then if I fold that in, you can see here, this is where, that is the run 17. Here are the two entries for 18, for 19, for 20, okay, 13, 14. Some are not that ordered. And in total, I have 42 events. 42 is generally the right answer, but is 42 the right answer for the log events that we should have here? No, because, well, we had a loop with 20 iterations, and each event or each run in the loop was creating 2 events, so we should have exactly 40 log events. Why do we have 42? The first thing that is kind of telling here is that you can see this one doesn't have a loop iteration. And if I open that, at the bottom you can see something what says grok parse failure. So basically the rules by which we have tried to parse that message were not correct. And then if I look at that, what do I have here? That's part of my stack trace. Does it make much sense to collect stack traces line by line? No, because they don't carry any, like one line of a stack trace is pretty meaningless. You only care about stack traces as a unit. So what is happening here is in my log file, we can just quickly head to the log file. We have a folder called logs here, and we have log to this one. So you can see here we have these lines, and every line makes sense, but what we also have here is you have this stack trace here. And unfortunately, we have broken up the stack trace because we've collected line by line. So basically, every time we have a new line, we assumed it would be a new log line, which is not very clever because this doesn't make much sense here. How would you fix that? Generally, you would define a multi-line pattern, so you can actually say, okay, this here should be one event. So we have that log line that is logging, and then we have the stack trace. And we want to combine the 3 so that you can see this is one event, and this event only makes sense if it's still combined and not broken up. So what you want to do is when you collect that, here, I've actually commented it out again, and you need to enable this. So basically what we're saying is, we're expecting a multi-line statement. There could be multi-line statements, and every line starts with that square bracket, because you see in our log event down here, we have a square bracket, then we have the date, the timestamp, the log level, the class where something is coming, the package where something is coming from, the class, and then we have like the session, the loop, and whatever the log message was. So basically what I need to say here is, if something starts with a square bracket, it's a new log event. If it doesn't start with a square bracket, it's kind of the stack trace to the previous event. And then you should not break that up. And this is what we're saying here. This also there are multiple variations of how to do that. That's from our documentation, so you can look it up because I always forget also how to combine stuff. But this basically describes how to structure those rules to collect log events the right way. So for example, if you're searching for B and you have the pattern ABB, like this is always the start of a log line, this combination of negate false and match after would collect whatever is before and then up until the last B until some other letter than B is coming. And these are all the 4 combinations you could have to make sure that one stack trace is combined with its log message. And depending on if you have the stack trace before or after, or whatever your pattern is, you could find and put everything into one log event. And if you do that properly, if we run that again now, let's run that again. So I'm adding another bunch of events. How many log messages should we have in total now? No, not 22. So 82. Yeah, 82. That is a good answer, and hopefully, let's see. If I refresh that, yes, luckily we have 82 now. That's the right number. You can see now we have done that correctly, and also now you can see we have that loop in every event. So everything was kind of put together the right way. You could, by the way, also visualize what is going on since we have nicely extracted those loop events. So generally you can see we have the method, the package, we have that loop count. We also have that session. The session is basically a random number, 1 to 100. We assume, well, this is the user session. Since I don't have proper users, just randomly generate that. And this is everything that we have extracted. So you could see, okay, how many debug messages. By the way, if you unfold that one here, it will show you where are your log events, or what log level are your log events. So you can see trace is 50%, which is not that unexpected because, well, I'm logging 2 events in every run, and every second one was a trace. And then you can see debug, info, warn, and only 2.5% are errors. You could also visualize that and see, for example, I want to create a new visualization and say, I want to use a pie chart on the parse index that I've created here, and I want to see which session is the most common one. And here I need to break down on the term, and the term is session. And you can see I want to see the top 15 sessions that I have added in my system. If you run that, you can see that 18 was randomly the most common session, which happened 6 times. 29 happened 6 times as well, and those happened 4 times, and the other ones just happened twice. Why do they always happen? Why is every session happening twice and not just once? Because a session is generated once per loop, and every loop is adding 2 events, so they always have the same session number. And that's how we can collect the sessions here. One other thing that might be curious is how I named my fields. We have recently created something called schema, where we basically say we are generally calling all the fields that you're collecting in a specific way, and then you can easily correlate them across different things what you have searched. And we will, for example, define if you have container information, how the fields are called for a container, like the container ID and the container name and the container tags, that they always follow a specific naming pattern. And you don't have to make up any naming patterns anymore, but you can follow our patterns, basically. And then there is often the question like, okay, how do I efficiently write these grok patterns? Because, well, we have that log line. You can see here we have those log lines. And basically, you need to parse out the relevant information here. So what you do is basically you can say, I want to copy one line. And we have in DevTools, this one here, we have a so-called grok debugger. And what the grok debugger is, you can basically say here is my one log line, and let me cheat because you probably don't want to see me type that because with all the square brackets I'm always mistyping. Let's say we copy this part here. Then you can add a grok pattern, and if you simulate that grok pattern, it will tell you what it actually would break out that log line, and if anything matches. So for example, if you say, oh, there is no space in between here, but this should be one after the other, it wouldn't find anything because those patterns don't find anything. But this way, you could put together like a proper grok pattern. So for example, here you can see, okay, we have the log level. This was the log level. Then we have another space, for example. And that needs to be quoted, put in curly braces. And after that, you have the package. And then you could say here, we could have just, I think, Word should be fine. Word. And we will put that into a field which we called log.package, hopefully. And you can see now we have split out the outermost level of our package, and then you could break down your stack trace or the log line into all the different pieces, and then you could parse them the right way. And this is generally the best way to do that if that grok debug. However, so this grok is just a named regular expression. So you can see here we have on the log level, we know what log levels are, and then I put that in the field log.level. So Warren here is being put in log.level, and we just parsed it. Who likes writing regular expressions? Anybody? Okay, one or two. I always called it the Stockholm syndrome, where you have been doing something for so long that you actually start to like it. Because I personally don't like writing regular expressions that much. We have recently added another thing to make that easier. Let me head over to that one. Here, this is machine learning. This icon is supposed to simulate the brain. Let's see how brainy it is today. And what this can do is it has a data visualizer where you can say, I have some data. I don't really know what it is or what it looks like. So let me head over to that GitHub, Java, logs, and I take the log line. Basically, you upload the log line that you have, and it tries to extract meaningful information out of that. So here you can see these were the logs we have in that file. It has tried to extract a log pattern automatically, so you can see it automatically detected the timestamp, it has automatically detected the log level, then it knew there were other parts, then it saw, okay, there is a session, and then it parsed the session, it found the loop, and put the loop here, and down here it actually extracted the log events. So you can see, okay, here, these are the trace, debug, info, whatever events. You can see it extracted the messages, the sessions, the timestamps, and you could just use that pattern and probably fine-tune that pattern to actually parse your events. That is very nice because you don't have to start from scratch creating your regular expressions always. You can start with that help here. Okay. I have already visualized the session. That was easy. We also have something new called the log UI. This is also very nice. The log UI basically is like a live tail. So here it shows you the information that it has extracted. And you could then just say, you stream that live, and then it's like live tailing. And then you just see the log events as they're coming in, and you don't need to refresh that Discover view, but you can just live tail your log events. But I guess you get the idea of a live tailing. I don't have to demo that now. And then we could monitor the pipeline. Since through Logstash, you can see how many events are going through. And you could see which parts in your pipeline do you have. So I run a grok pattern here. I extract the key value pattern. I put that whole thing into Elasticsearch in this index or in that index. And it could also show you how many events are you processing and where you're spending your time. This is very helpful if you have a slow Logstash pipeline to debug where are you wasting your time. Because depending on how you write your regular expressions, they could be much more efficient or less efficient. And that tool will help you to figure out where you're spending your time. So the good thing about this approach in general is you don't need to change how you log, because you just keep your log lines. The bad thing is, well, you need to write that regular expression. You sometimes have problems around timestamps, and especially for multi-line statements, you need to be careful to not break up stack traces into independent parts because they don't make much sense anymore. So the next thing you could do is you could send your data to Logstash directly. So basically, you have the information structured in your application, and it's kind of stupid to write it out to a log and then parse back that log, because your application already knows what is what field. So what that looks like is you have a special log appender that can send the data directly to Logstash, and Logstash will just forward it to Elasticsearch, which is simple enough. Just to give you the idea of what that looks like, since we haven't, no, not Slack. Since I haven't really shown the log appender here, in the log appender, what we are doing here is basically we say, here, instead of writing it out to a file, like I guess most of you know like how patterns for a file look like I define the file, and then I have the pattern, which looks something like this. This was the pattern what I've written out. Here, instead of defining a pattern, Logstash just knows what are the fields, because the log back appender is sending you that. And here I'm just telling you, okay, here, take my inputs and store everything directly. Since we've been running that a few times already, we should have events. If I go to the send index, how many events are you expecting? This time it should be 40 or 80, depending on, because it's only the last 15 minutes and I've been talking enough so that probably the oldest events have fallen out again. But here you can see we didn't need to structure anything. It just forwarded the right kinds of information. So you can see we have the log level, we have the loop, we have the session, and we have the message, which is maybe investigate tomorrow, and it just got the right information. So this looks very convenient. Any guesses what could be the problem with that approach? Or why might this not be ideal? What happens if either Logstash is down or the network is down? So what logback, the log appender will do, it generally sends, it has an async thread in the background that will send you log events. However, it buffers the events it needs to send. And that buffer by default is 200 megabytes large. So if either your network is down or Logstash is down for more than those 200 megabytes of events, the oldest events will just be discarded and you will not see them. The other thing that is kind of not so great is, especially when the network is down or when something is broken and you don't really know what is going on, then you want to see your logs. But you cannot because, well, you cannot reach a destination and you can't see into your logs. So that's sometimes, especially for debugging stuff live, it's very painful when you don't get the logs directly. So that's why we are sometimes a bit skeptical if that is really the right approach to take logs. Also, you have more of more coupling because in your application now, we have defined the Logstash endpoint where we send the data. Whereas with the other approaches, we just write out to a file, and then we have the configuration of how to collect that file outside. So your application doesn't have any idea how to do that. So it's kind of nice, more or better decoupled from your logging system. And well, in outages, you don't see anything. The advantage is you don't need to write regular expressions, and you don't need to write out to that file, because, well, there is no file to parse. The next thing you could do is, your application has everything in a structured format, so why not write it out in a structured format as well? Which would be, you write out JSON from your log appender, and then FileBeat can basically just collect the JSON, forward it to Elasticsearch, and since Elasticsearch is storing JSON as well, there's nothing more to do. You're already good to go. What that looks like is something like this, where you basically say, okay, here I have my JSON file, I want to collect that as JSON, and I say, okay, the entire message is under the key message, and I want to put that into the message, into the document, and I want to store the entire thing. Here it's probably most easy to show you, okay, what does the log look like? It's, well, here, instead of a log line, you have a structured event, you have a JSON. And then you just forward that, and in Elasticsearch, if we send to the structure index, go to the structure index, you can see we have our 40 events. And you can see here we have all our events. And well, they arrived in the right, or like with the right fields, and we didn't need to do any parsing. So that's very convenient. The one main downside is you might have some overhead for JSON deserialization, or serialization and then deserialization, because, well, writing out JSON is kind of a bit heavy. But normally that's not so much of a problem. And this is also the approach we would recommend if you can. So if you can just switch out the log appender, this will make you the least problems because you don't need to do the parsing. It doesn't matter if your network is down or if Logstash is down because you still have the file, the event on disk, and you can just collect it from there. And that's all you need. What happens if you containerize? And when I say containerize, I assume everybody is using Docker, right? Pretty much. Normally, very few people are using something else. So when you use Docker, where do you put FileBit? You could put it on the host, but you can also put the FileBit in a sidecar, and then it's just running next to your application in another container, and then getting the logs. And then you have two approaches how to get the logs, or what, depending on where your application is logging. The first one is your application is logging to system out, and then all the events are ending up in the JSON default log. And what you basically do is you need to collect everything from the JSON default log here. That would be the right path for that. And here I assume, well, there is a JSON message in there. I want to collect that. And I'm also enriching that with the Docker information. So what the Docker information enrichment would be, for example, in your log events, down here there would be the log event. But what you can also see here is you see the ID of the Docker instance that is running. You can also see which image is that based on, what is the name of it, and which labels did I apply. So you have that additional meta information and can filter out of that or for that in your logs. So you could just say, give me everything from the Java containers, or give me all the events from a container with a specific ID. So that would be possible here. And if you're logging out as JSON, and then those JSON events are being put into the JSON message in the default JSON log, you have basically JSON in JSON, and it will all be / escaped. So to get the actual message, what you would need to do is you would need to say like, hey, I know there is a key message, and that contains JSON keys, or that contains a JSON document, and I want to actually get that specific JSON doc inside there to be extracted. And then you could extract that into your log or in Elasticsearch, and then you would have all the fields nicely structured in there. The other thing is, if your application doesn't log to system out and writes a regular message still, you can also collect that. So basically what you do is you would mount the log folder out of your container and into the sidecar container, and there you would just collect it the regular way. And this is what it would look like. So basically here you have your Java Docker container, and that logs to that bind-mounted directory here. So it logs to that folder outside of the container. And then in your FileBit sidecar, you would just take that same folder, mount it into your sidecar, and then send that information to Elasticsearch. So basically, you bind-mount the directory into the Java container, there you log, then you bind-mount the same directory into your sidecar, and there you collect the logs, and then you forward them. And you don't need to install anything on the host. That's the general idea. One thing that is kind of important is we have this so-called registry file, and the registry file keeps track of in your log what have you been sending from your log to Elasticsearch, for example, or Logstash. And it is basically a pointer in the file and knows what you have sent and what you haven't sent yet. The problem is if you replace the sidecar container, because maybe there is a new version of FileBit, and if you keep that registry file in the container, it would start recollecting all the logs again, because it doesn't know what it has already sent or not sent. So what you should do is you should also mount that registry file outside of the container. So even if you replace the container, it will still know what has already been sent and what hasn't been sent. And you basically do it, you externalize that registry file, you say it's under that path, and then you mount it into the containers. You can, by the way, in my demo, you can see here, I have this registry folder, and this is basically the pointer that you have done here. Here we have a registry file, and that registry file tells me for this file, so for example for the Java logging JSON file, we are at this offset, and this was the last time we have collected logs from that. And this is all the meta information we need. And this is, by the way, based on inodes. So even if you do file rotation, we will still remember where are we in that file, because it's not based on the path, but on the inode, and the inode doesn't change when you rotate the file or rename the file. And this is how we keep track of where are you in the file and what has already been sent and what hasn't been sent. And if you keep that outside of the container, you can replace your logging container or the sidecar any way you want, and it doesn't make any difference for your application. Okay, Some applications like Redis try to be fun when they start up and they log something like this ASCII Art, which is nice, but this is garbage for centralized logging. Nobody wants to centralize that. We have another nice feature where you can basically define conditions in your log or in your log appender and then exclude specific events. So here, for example, what I'm saying is I want to take this auto-discovery rule and first I define a condition. And the condition is if I have a container running that is based on the Redis image. So we have a Redis container running. And then I want to apply some configuration. And the configuration is I take that ID that I have extracted from above, and then I want to exclude those specific lines. So this is basically the workaround how to kick out that ASCII Art. So whenever there is a Redis container being loaded, we will auto-load those rules and then filter out the ASCII Art when it starts up. So you're not filling up your centralized logging with garbage like that. Also, if you have any parsing rules, obviously your parsing rules would fail on that because you probably don't have the right rules to parse ASCII Art. There is one, I've shown you the infrastructure UI already. The good thing about Docker is it's kind of hot. The bad thing is it kind of adds complexity. And we see that since we have official Docker containers or images, like half the questions there are actually Docker questions. So most of the time we're kind of doing Docker support on the side because, well, a lot of people are starting with Docker and then stuff can get very confusing. But we're happy to answer Docker questions as well. Okay, and then you want to orchestrate at some point probably. And I assume when we talk about orchestration, we talk about Kubernetes, right? And not something totally different. Okay, in Kubernetes, where do you put your file beat? You can put it as a daemon set, and a daemon set there you can basically define there should be one instance of file beat running on every host that I have in my Docker cluster, in my Kubernetes cluster, and that one will collect the logs for all the other systems. Then you need to bind mount the directories the right way that you collect the JSON log file, and then you will just forward those and you're good. You can also get metadata from your Kubernetes cluster, and if your file beat is running as part of the Kubernetes cluster, you could just say like, hey, you're part of the Kubernetes cluster, get the metadata. If you install FileBeat on the host, for example, because you don't want to run it as part of Kubernetes, it could still connect to the Kubernetes API to get metadata of whatever you have running. And that would look like this second example. So here you need to pick either this one or this one. This one if FileBeat runs as part of the Kubernetes cluster, this one if you don't run as part of the Kubernetes cluster. And here you basically say, okay, this is the host I want to connect to, and that is the kube config I want to use. And then you can basically query the Kubernetes API to get additional metadata. And what that would look in the end is you then have the container information, but you also have Kubernetes information, like you see the namespace, the node, the pod. All of that information could be enriched into your logs, and then you know where that stuff is coming from. So you can say like, oh, give me just the errors for one specific pod or namespace. You can use the same ASCII Art trick here, again, to kick out the ASCII Art. Basically, instead, here we're saying, okay, this is the Redis namespace, and everything in the Redis namespace, filter that down to those containers, and then kick out the ASCII Art. That's what we're doing here. One other nice thing that you can do is you have here, we're defining if we have a Kubernetes namespace, use that as part of the index name. Otherwise, if there is no Kubernetes namespace, that's the colon syntax, like if there is this one doesn't exist, then use FileBeat. And then the beat version and then the date pattern. So this way you could say like, want to have different indices, and I want to have every namespace I have in Kubernetes should go to a different index in Elasticsearch. And then you could just search within that index to search within that namespace. Or you could just give users the permission to search on that specific index and they only see what is in their specific namespace. You can also search across namespaces afterwards because you could just define a pattern or an alias to search across them. But this way you can actually say like I want to break where the data is coming from. It's kind of even hotter, but it's also even more complex. And if you come with complex Kubernetes questions, we're probably not going to answer them as part of our repositories because we're doing our products, but we're not doing Kubernetes support on the side. Okay, other stuff that might be interesting. Is anybody using like a hot-warm architecture or hot-warm-cold? This is also pretty common, especially if you have like this daily naming pattern. Like here, you could see like we create a new index for every day. That is the last part of the index name. So we have the version that we are running that is only to avoid collisions if we change anything in the mapping. And then we create, for every new day, we create a new index. And what you can then do is if you have like a or if you have a bigger infrastructure, you might break stuff up into different tiers, basically. Because if you have the daily index pattern, you're only logging to today, basically. Only the index that contains today's logs is getting writes. Yesterday's index is not getting any writes anymore because you have collected all the logs from yesterday already. And even all the logs are getting even fewer. They're definitely not getting any writes. And then you also have like different tiers of searches probably, because most of your searches are probably for today, because you want to see what is happening in my application now. So that will also get most searches. Maybe you're searching like yesterday's to a week ago, the logs on a more or less frequent basis, and then you might keep around all the logs that are older than a week for compliance reasons, or you very rarely still search them. So you could have different nodes to have like different types of hardware architecture. So you could have very powerful nodes for today's index because you know you have a lot of write operations and a lot of search operations. Then you have slower disks maybe for yesterday's data. And if it's older than a week, you just have the spinning disks and you use cheaper hardware. And that is then to have this structured hardware approach to keep the hardware costs down for that. We will soon, that is not available yet, unfortunately it will be next year that we will bring that out. We will have something called index lifecycle management, which will actually do that for you. So if you have a larger infrastructure where you have different node types, it could do that for you. So you could say, hey, I have a hot phase, and the hot phase, I'm putting 3 gigabytes of data into one index. And then after some days, 0 doesn't make much sense, but let's say after 1 or 2 days, I move that whole thing to a warm phase. And there I, for example, shrink the index and do some optimizations on that and move that to a different kind of hardware that is maybe a bit lower. And then here we're leaving out the cold phase, but you could potentially have a cold phase as well. And then you have a delete phase. And you say after 30 days or 90 days or whatever, I want to delete the logs because then I don't need them anymore. How long are you keeping logs? The answer is probably it depends. Normally when we talk to somebody, especially the business units, we ask like, how long do you intend to keep the logs? And then they say like, a year, because that's the first thing that comes to their mind. And then we say, okay, let's see. You're logging X gigabytes or whatever per day, so that will mean that many instances. And that many instances mean that cost. And then they're like, okay, maybe 30 days is fine as well. So that's kind of like some common pattern that we see, that once you calculate what is the actual cost of those logs, people change their mind. But it totally depends on your business, and maybe you have legal requirements as well, so you might need to keep logs around longer. We're also adding something which we call the frozen index, and the frozen index is basically, so we have closed indices which are not searchable in general. What a frozen index is, basically, you can thaw it up. So basically, you open up a frozen index, and then you can look into what data do you have, and then you close it again. It will be pretty slow to search like that, and it's limited in the number of parallel operations that we allow, but it will allow you to keep much more data on one node, so to keep the density higher, or also to have like a much lower or smaller heap in comparison to how much data you store. So if you have like this compliance reason where you say, oh, we need to keep 5 years of data, but it's very expensive on regular nodes, you could have these frozen indices where you could then keep like 5 terabytes or more of data probably on one node. So you just keep all those very old logs for compliance reasons, and every now and then when you need to search them, which might be every few weeks or months, then you run that frozen search where you basically open up one index, search it, and then close it down again. It will be slow, but it will give you kind of like a much cheaper approach to keep data long-term around, which might be nice. And then we also have centralized log session beats management. If you say like something in my configuration changes and I want to configure that through a UI, you could do that in Kibana as well now. Okay, to wrap up, if you want to have the code that I've shown you, this is where all the code is living. That's probably one of the more relevant URLs here. And there you can see all the examples, and I'll probably push updates soon again when I change something or try out something new. So this is where the code is living. Then, what did we talk about? How are we doing time-wise? Oh, we're doing okay. So parse is, you have the regular log line, and you need to chop it up again by writing a regular expression if you want that. You could send it directly to Logstash, where you don't have to do any parsing, but it has the downside that, well, if the network is down or if Logstash is down, you're not going to receive any events. And probably you want to see your events mostly then when something is not working as expected. What we generally would recommend is that you log in a structured format. It could also be like CSV or key value or whatever. But if you have JSON, that's easiest for us because we can collect JSON directly. Then you can just forward the JSON. If you have Docker, well, you can add metadata, and you need to figure out, are you logging to the default JSON log, or are you still writing out the file from your application? And then, depending on where you go, you will need to collect that. And with Kubernetes, well, it's getting even more tricky where to put stuff and how to collect it, but it's generally the same approach that you're doing there. And with that, do you have any questions? Did anybody post any questions? Yes? Okay. So I'm nodding. Let's see. What is the minimum recommended number of log lines to give to the ML analyzer to find a good pattern? So that analyzer is brand new. It came out in 6.5 as the first time, and it's, I think, still marked as beta. I think it doesn't need that many log lines. It has actually a limit of how many you can get because it might run out of capacity. But I think if you give it just 10, it might already also work, but I don't know, so we will just try it out, I guess. Let me head over to my log file. Let's say we only keep 5 lines. Does it make sense? Let's only keep 5 lines. Let's store that, and let's load it. And I think it should figure that out fine, but I haven't tried it, so let's see. Where's my brain? Here's my brain. So we want to load that log file. Okay, that was not enough. Interesting. Okay, let's see. Maybe if I give it like 20 lines. No. Let's see if it's 4. Let's do 50. I'm not sure we have like a hard limit, or if that is more trial and error. But normally I think you will have the problem that you will have too many lines probably, and not too few. And you need to find a reasonable subset. Okay. 50 seems to be okay. I don't know what is something between 20 and 50 obviously, which is the minimum. But here, well, we have analyzed those, and it found the same pattern as with the full file, and it could extract all the other pieces of information. So that looks good in my opinion. I guess it depends a bit, but obviously more than 20 lines. And then you see how that works. Any other questions? No? Then thanks a lot. And if you have other questions, come to me afterwards. I have also a bunch of stickers on the table in the back. So if you want to grab stickers, they're there. Thank you.